Welcome. My name is Brian Pistolka with Mapei Company, and I'll be working here with Robert Manchetti from the National Gypsum Company, who is the director of their technical testing department in Buffalo, New York, which is involved in the testing of the sound membranes. This is available for continuing education credits for those of you who have applied. Let's look at the mission for today, or the course objective. We're going to be talking about sound reduction membranes and sound values as they relate to the ANSI specification. The four main objectives that we have that I would like everyone to be able to accomplish during our brief course and review of this would be to understand the approved industry standards and the methods for sound control membranes, to be able to recognize the difference between impact as well as airborne sound dampening, and also to understand somewhat of the differences of how the layering system and the testing arrives at those different numbers that we'll be talking about. Understand how to compare the marketplace products, to look at all of the different products that are out there and look at the features and benefits to be able to make the selection for your project or for your job or specification according to the capabilities of those particular products. Identify the tools available that will help you in that selection to choose the right membrane for the project that you're looking at. To begin with, what we want to do is to tie this into the ANSI specification, which was designed around sound control membranes and the properties that were established to determine and select amongst the qualifiers for your decision. To begin with, we'll be talking about the scope of the specification, the different definitions. We'll talk about the sampling and testing procedures, the test and material properties, as well as the system performance, to give you an idea of what that specification is based upon and how you can use that in the selection of the membrane of your choice. Looking at the areas that we'll talk about briefly through the course of this presentation, we'll be talking about the definitions of sound reduction, the types of bonded sound reduction membranes, and this specification is designed only on bonded membranes. There are other membranes out there, but this particular specification is only developed for those that are direct bonded for thin set tile installations over the top of these membranes. We'll talk about how the membranes are tested to give you an idea as to what the test is, whether it's sound or whether it's tensile pull, the particular attributes that are required and detailed within this specification. We'll look at briefly floor assemblies as well as ceiling assemblies to give you an idea of how you're specifying and how it affects the particular project or the job that you're involved in. We'll talk about the pros and cons of the various membranes and then look at how to select the sound membrane based upon the parameters that you are looking for in your particular situation. We will talk about the sound testing methods. At the end, we will have a question and answer section, so we'll leave some time at the end to answer questions and proceed in that fashion. Looking at sound reduction membranes, there are many uses and many trends regarding sound. What you'll find is that many of the condominiums, the apartments, are definitely advancing in the use of sound control membranes as it's driven by the end user. The end user may make their selection on an apartment or a condominium based upon the sound, or they may move away from one based upon sound. That is the biggest issue facing apartments, condominiums, and I look at soundproofing as really, it's not for you in your particular environment. You're doing it for your neighbor, but it's because of the code associations and the condos that drive everyone in that development or association to have a requirement for soundproofing. Let's look at some of the key success installation to make for a successful installation of sound control membrane. You would be looking at following this specification, which we are talking about, the 118.3, which we will cover in detail as to what is all involved in it. Looking at the ASTM 2179 is another important specification. Review the membrane test assembly. Make sure that you are familiar with whether the spec requires with a sealing or without a sealing, because that is going to be important as to the numbers that you will arrive or derive from the testing. And as it goes, the higher sound rating is achieved with a drop sealing. The higher the number, the better. But the important thing is to align the test system with the particular installation or project that you are dealing with in that point. Naturally, do not cover the movement joints. We will talk about that in a little detail later. But let's get into the introduction of the specification. As I mentioned earlier, it is only for bonded sound reduction membranes. For thin-set ceramic tile installations that lower the transmission of sound from one floor or to the room below. Now, this standard applies to liquid membranes as well as applied membranes or sheet membranes. Looking at the standard was developed to assist specifiers and installers with a minimum criteria. And I mentioned minimum criteria. If you look at the specification, that is not the end game, because if you look at the bond strengths or the requirements as far as the delta, that is the bare minimum that the specification has established as an acceptable product. So if your product does not meet that specification, it would not be a good idea to be using it. And then there is a wide range of products and performance over that, but the specification was set as a starting point for the industry and a qualification related to sound. If you're looking at systems outside of the specification, then additional testing would be required. Let's look at some of the variety of sound reduction membranes out there. Some of the common players are no doubt cork. Cork goes from a 1/4 inch to a 1/2 inch in thickness. One of the considerations with cork is the thicker, the better the performance. So make sure that when you're looking at the test reports, you align the actual thickness of the product with what you're using on a particular job. There's also cementitious and adhesive mortars for sound control. Looking at rubber and synthetic polymer is another group. They typically range from 3 to 5 mil. You may find some rubber products up to 10 mil in thickness. There's a range of products that are associated with sheeting, which are polypropylene or chlorinated polyethylene foam, or you'd have recycled foam or bitumen as they refer to it as, from 40 mil to up to 110 mil in thickness. Looking at membrane methods to control, there's two ways of controlling sound. One is by absorption, and the other is by separation or barrier. So that is how the membranes achieve the performance that they accomplish by one of those two methods or a combination of those methods. But for the purpose of the bonded membranes, we will be looking at absorption as the method for the products that we had talked about earlier. Looking at the scope of the specification describes the test methods that are looked at in this specification, and are the minimum requirements. Sound reduction membranes are a key part of the overall system, and this is important to remember. The membrane isn't the only thing that's giving you the result. It's your entire system that has an impact upon your sound performance. So be looking at the membrane closely because it's key, but also be evaluating everything else that you're looking at within the system, because it also involves the flooring material as well as the ceiling assembly. And we'll be getting in later into the particulars of test reports and some of the ins and outs of the results that you will see from these. The important consideration also to mention in this specification is the perimeter joints are properly filled for the manufacturer's instructions. You can have the best system out there, but if you're not dealing with the perimeter joints properly, you're defeating the purpose of using the membrane that you are using. Always consult the manufacturers and architects regarding the requirements of expansion and control joints. I'm not going into much detail there, as that's a common situation that is carried through with the soundproof membranes. Looking at some of the definitions that are in the specifications, it talks about the latex modified Portland cements that are used to bond the tile in the membranes. It details the acoustical joint, and this is the primary function is to achieve and maintain the sound values of the system with this acoustical sealant. So that is the key point that I want to draw to there. The movement joints are the same as a standard. Ceramic tile, just be aware that different tile lead to different results. And the test specification allows for the 3 different types of tile to be tested, but be aware that the different tile lead to different results. And in this particular example, we'll talk about the type X, which is the porcelain tile. But looking at, to give you an idea of what the manufacturers need to do to verify that their products meet this standard specification is multifaceted. To begin with, they need to bring in a sample of their product and do a sample preparation. Now, all of these specifications require the same uniform treatment of the test so that the results are comparable. If you look at the sample preparation, as we see on the diagram on the right, a sample is prepared with the exact membrane and setting material that you are going to use in the procedure that you are going to test. You prepare the samples, and all samples are tested under the same conditions in reference to the environment. And the environment is important in reference to the test because materials set at different times, and we need to look at a situation with a control environment to maintain the comparability of the different samples. And then the test values are recorded. Looking at the materials and the properties, one of the tests relates to fungus and the microorganism resistance. Now this is a test that you would take the existing membrane that you are going to be testing and compare it to a control. And your approach is designed, on the control you want to definitely have the group, which is the nigroorganism, which is a type of black mold. You want that to be present on your control to prove that the spore is active. But this is one that, again, the conditions and temperature and humidity and the incubation are a format that needs to be followed so that when you meet this specification, you can be assured that the product is not going to grow mold and mildew. And one thing I would point to in this industry, the specification, be sure that you look at how the manufacturer reports the specification, because in some cases they may say meets X property of the specification, but you really want to meet the entire spec or it is not applicable. The product needs to meet every category of the specification. As we talked about, it's a minimum spec at best. So if they're only reporting one element of meeting the test, it should be a clue to you that you need to check further to make sure and contact the manufacturer to ascertain that it meets all criteria within the specification. One of the other specs relates to the shear bond strength that's developed with the membrane and the mortar. What you're looking at is when you're doing a shear, From a manufacturer's perspective, everything has to be uniform, including these cement blocks that you are testing. Their water absorption has to be the same. Their exterior finish has to be the same so that the tests relate from test to test to test. Looking at preparation of those shear bonds, they have to be prepared with an offset because what you'll see in this machine, in this particular case, an Instrom, the assembly will be set up in that Instrom, and after it's cured the proper amount of time at the proper temperature, you will conduct a shear because you also want to know what is the bonding capability of that tile to the membrane. Not only are you concerned about sound, but you're concerned about the performance and longevity of that installation, and the bond is a critical consideration that is aligned with the specification. Another part of the specification is the Robinson floor test. Now, the Robinson floor test is conducted with an assembly, in this case over concrete, the sound reduction membrane. The mortar is specified as meeting 118.4 or a latex modified mortar, and the grout is meeting 118.6 with a 1/4 inch grout joint, and the type X tile is the porcelain tile that we talked about earlier. Now, when you do different tests, you can get different results. If you use an epoxy mortar for setting, or you use an epoxy grout, you're going to get better results on the Robinson test panel. But what I want to convey is there are a lot of different avenues when you're looking at soundproofing membrane. It's just not the soundproofing, it's the performance of the entire system in reference to its bond, as well as whether it can be used in a residential installation or whether it can be used in a commercial installation. And that's the purpose of the Robinson test panel being incorporated into this testing system, because you want to define at what level of performance is your membrane capable. Is it a heavy commercial? Does it receive a heavy commercial rating? Or is it limited to a residential rating? In this particular spec, again, we talk about the minimum, which is a residential rating, and the different products will rate at different levels depending upon their flexibility. And the secret with sound is typically airspace helps in getting better numbers, but it hurts you in regards to a product tested on the Robinson. So from a manufacturer's perspective, the sound control membranes are a tightrope in order to get a product that performs great in all avenues. So when you're looking at comparing one product to another, be aware of the differences and be aware of what you need in your particular project. Because if you need a project that has a higher rating requirement for a Robinson, then maybe a product that has a better sound number will not fit the bill. Because you'll have cracks associated with the installation. Can we wait till later for the question? Thank you. Okay. But that is based upon the performance of the Robinson, and the Robinson is the same piece of equipment that we use for testing all of the service ratings, but in this case it's used for the floor covering or for the membrane, the sound membrane itself. And if you look at residential, as we mentioned, is the bottom performance. In most situations where you're using soundproofing, you're probably in the residential to light commercial avenue, because if you're looking at apartments, you're looking at condominiums, you're at the need of a residential or light. But when you're looking at office spaces, you may be looking up to more moderate traffic, depending upon what you're going to be rolling over the top of it, or what type of additional exposure that the floor is going to have to weight or to other things besides human traffic. Looking at the sound transmission and testing, The ANSI 118.3, if we get into a little detail in reference to that component of the test, that's where Robert from NGC will have more in-depth knowledge in reference to the particular equipment because they do the actual testing. But from a test perspective, you're looking at two rooms. You're looking at the room above and the room below. In the room above, you would be putting the tapping machine on there, and then you would be measuring the value in the room below. Your test substrate would be a concrete floor, which is built according to ASTM standards. The membrane would be applied over the top of that concrete and the tile. And here's where we're talking about what goes into the assembly, which has an effect upon your test results. By changing what you're plugging into the assembly, you can have an impact upon your results if it varies. With the membrane certainly will vary, whether you're putting in marble or whether you're putting in porcelain tile, there may be a variance. Looking at the grout, it will affect with an epoxy grout, you'll get a better rating on the Robinson, things like that to take into consideration. But they're allowed to cure for 28 days before they're subjected to the testing to give it a proper cure before running the testing on the product. The test apparatus, as we talked, is the tapping machine, and it needs to meet the ASTM requirements. And the testing is performed with the ASTM floor assembly to obtain an IIC of 10 or greater. This is the specification that is in the ANSI. It is a beginning specification as I look at it, as 10 is not an overly impressive number, but it was a specification to begin with to say, hey, we need to establish a minimum base and do the delta IIC as a comparative number within that specification. Let's look at some sound reduction testing methods. Now, what we'll talk about today is a lab where you're talking about a controlled environment. And that's very important in regards to making sure that you're comparing one membrane to another membrane in the same exposure, because different situations will have a different impact upon the numbers that you get. Looking at, there are other tests out there not aligned with this specification, but be aware that there are other methods and field tests. Now, there's a lot of confusion in the industry in relation to field tests. Everyone always expects the field test to be a correlation with the lab, but there's a challenge in the field test if you're looking at the many variables that you'll run into when you're doing a field test, because the room size is different. You've got furniture in the room maybe. You have outside construction noise. You may have inside construction noise. You may have condominiums or apartments next door where they're actually the plumber's working, or so you have all of this variation that enters into your field test, and that's why the laboratory test in the controlled environment is going to be a more solid comparison. Also will affect sound would be the heat and humidity and the temperature. All of that is controlled in a lab environment, but relatively uncontrolled on the actual job or field site, because in many cases they may not have all the windows in, or they may not have the air conditioning working. It may be hot or sweltering. So all of those on the field will have some impact on the test that is resulting. The IIC is the test, or the delta, to try and separate the membrane performance itself. Looking at the IIC, this is the one number that if you're only going to look at one number, that would be the number that I would recommend looking at, because it gives you the correlation associated with that particular membrane and that particular system. And it's an easier comparison than going through all of the other detail if you're only looking at one number. And there's a lot of confusion in the industry where if you look at the reporting of performance and numbers, many people only show you one number. But as we're learning, it's critical to ask questions related to what is that number associated with as far as a system. What is the floor assembly? What is the ceiling assembly? What is the delta of that product? Looking at to understand sound in the definition, airborne sound is the STC class. What you would be comparing when you're talking about airborne sound would be projection of my voice, stereo, vacuum cleaner, air noise that is transmitted not based upon impact. Now the impact class would be such things as footsteps, dancing, moving furniture, or rolling things over the top of it, or dropping objects. It would be the actual impact on that floor that would translate through to the room below. Looking at the sound transmission class, this is tested under ASTM E90, and it's the measurement of the ability of that flooring system to reduce that airborne sound from transferring through to the occupants below. Looking at the typically numbers are 1 to 2 digits, and they indicate the decibel reduction in airborne sound. A typical building code is 50. Now it varies from state to state. Some counties, even within the same state, have higher demands than their sister counties do. But check with your local codes. 50/50 is a general guideline in reference to what performance is typically looked for. And we mentioned that the higher the number, the better it is from a sound control perspective. Now the impact insulation class is also under ASTM E492 and ASTM 2179, and it measures the ability to reduce those impact sounds that we talked about, whether it's dropping, footsteps, dancing. It's measuring that ability to reduce that sound from transferring through to the room below. Again, it measures it in decibels as the mode of measurement, and the minimum code is 50. In some areas you see a 50-52 where 52 IIC is required, but it really depends upon the market and their establishment. And some markets are not well defined at all, so it behooves you to check with the local codes and see what is established. What we talked about is measuring decibels, and they'll be measured with a decibel meter, and it's a device that's used to measure sound intensity. To put in perspective what we're talking about with these numbers when we say a minimum of 50, a whisper is at 20 decibels, speech is at 60 decibels. If you're looking at a vacuum cleaner, it's 80 decibels. Loud music is up to 100, and a power tool is 110. So it gives you a perspective as to if something is reducing it by 50 decibels, what it's really limiting. Let's look at the upper unit system as we relate to sound reduction is really the combination of the entire system, which is not only your slab, but the lower system below, which is the ceiling mechanism. If you look at the upper, it's the floor assembly, which includes the wear surface, whether it's tile, grout, wood, the setting material, the bonded membrane, looking at the membrane material that's used to bond the tile, as well as beginning with the subfloor. So typically the subfloors depend on markets. In Florida, where I live, everything is 6-inch slab. Other markets like Chicago, it's 8-inch slab. So it varies depending upon the market that you are in. But make sure that you're looking at a test report that's aligned with the assembly that you're specifying or building or working a project on, because it's important that you dig a little deeper than just looking at a number that says 72. Now if we look at the lower unit, when we're talking the ceiling assembly, what you want to know in that test report is what type of ceiling assembly was tested. There's many ways of doing it. You can do it with just no ceiling whatsoever or just a gypsum. Some of them incorporate an airspace into the system. Others include insulation, airspace in that drop ceiling. And the no suspended ceiling is the one that we talk about in certain markets like Florida. That's very popular. So what we're looking at is really understanding the entire assembly. Just got a couple examples of here. One is a 6-inch concrete floor, figure 1 with the suspended ceiling, and it actually has the airspace in there. All of those have an impact upon the performance and the numbers that you will get. Figure 2 shows a concrete floor with minimum insulation and some drywall ceiling below. Looking at figure 3, which is outside of the parameter of the specification because the specification deals specifically with concrete, but this is an example of a plywood base, which in some markets they're dealing with in apartments, but it's over an engineered joist. It has airspace, hangers, and then the drywall below. So all of those, what you want to be sure is that you align what the job is with the test report, because the test reports sometimes may not coincide with what you're actually installing, which would not be then a true read of what you're going to get with that system. And that's the importance that I look at, is compare apples to apples when you're looking at the information and the system that you are working with. The trend is towards a 6-inch slab with no suspended ceiling, but there are other systems out there. The delta, as we talked about, is very important, and probably the best way to compare one system to another. When specifying the sound control membrane, does the test method reflect the installation requirements of the project? That's the biggest question that you need to ask yourself and of most relevance as we're talking about sound. Also be sure that the ceiling assembly that you're looking at relates to what you're actually looking at including on the job site itself. And here we're looking at some of the sound test equipment, which Robert will go into more detail with, as NGC is an independent lab that conducts all of the sound testing, so he can give you a lot more insight into how the tests are conducted and the equipment that is utilized. But it also involves the floor-to-ceiling assembly, the sound control test room, and the management of that data. This is just a typical test report that I wanted to use as an example, a peel and stick membrane. If you look at the impact of this, it's on a 6-inch concrete slab with no ceiling assembly, and the rating for this particular one is at 50, IIC, a delta of 21, and an SPC of 52. So those are how you would see many report membranes reporting their test results, but it's critical that you look at their information or even ask for their test report to validate what tile was used, what substrate was used, what was the thickness of it, was there a ceiling assembly included, and look at the test report to see how it was installed, to see if it is installed the way that you're going to install it. Was it put down, per se, with this one with the primer, and did they use a regular mortar over the top of it, or did they use a mud bed? It is important to look at that test report, and within the test report it is well defined the system that was built and tested, and you're going to want to look at that to make sure that what you're comparing is what you're looking to achieve. This is an overview to give you a perspective of the membranes and the different types and how to rate them. As we mentioned earlier, there are many different properties within a membrane, but what you're looking for is complete performance. Some membranes do better in moisture conditions. Some do very poorly in moisture conditions. Some of the membranes have an easy labor cost associated with them. Some of them are a little bit more complicated and a little bit more intensive in reference to the labor that is required to install it and to go over the top of it. So you're going to want to look at compressive resistance. The membranes that may do the best on sound may have a challenge with compressive or rolling loads or point loads, such as that grand piano in the main room in the condominium. That's a lot of weight at a particular point. So what you're going to want to look at is how is that membrane or installation going to be used, because you're going to want to align the membrane with the requirements that the installation is going to be subjected to. Mold resistance varies depending upon the type of membrane as well. As we mentioned, exposure to water, if you're looking at running your soundproofing through the entire areas, and which is a trend in most areas, in the kitchens and the bathrooms, you're going to want to take into consideration, is the membrane good when it's exposed to moisture? Does it cause problems with mold or mildew? Does it cause problems with bonding? So this is an overview that gives you a perspective of the different features and the different challenges of the different types of membranes, so that when you're making your decision, you can align the limitations or the performance of the membrane with the particular requirements of your installation. Let me touch briefly on how do I select a sound reduction membrane. We just looked at some of the comparative products. We talked about the different test procedures. And what you're going to want to do is look at whether it's going to be residential in nature, or is it going to be heavy commercial in nature. So with that, in fact, it may drive you in a different direction regarding the membrane that you're selecting, as not all of them perform as equal when it comes to the Robinson test panel, and that's a consideration because you're going to want to take into account that if it has too much movement, you're going to have other problems which would be associated with cracked tile. Is it compatible with the substrate? It's going to be important that you're aware of the building codes in your area or any other requirements that are specifically associated with the building codes in your market. This is one that I would recommend, is obtain documentation from your manufacturer of your sound control membrane. Get a copy of their actual test report, because many of the brochures are marketing related. You want to show your system in the best light, you want to show the best number, but if they don't have the details on how that number was arrived at, it is rather pointless. So in order to get to the chase, the best is to discuss with the manufacturer, let us see the test report and the system that you tested and the numbers that you arrived at, and how you got to where you're promoting, because that will separate a lot of confusion that exists in the marketplace. Also, it needs to be done from an independent lab. There are no labs out there that are not certified. If there's no ability for a manufacturer to do his own sound testing. We've in the past hired engineers to try and speed along our process of development, but the only way to really tell what your system is capable of is to submit it to the certified labs and conduct the actual testing itself. Ensure compatibility of the materials. Some of the membranes out there have excellent performance on sound, but if you look in the details, you'll see different recommendations from different material manufacturers as to whether you can set it with a urethane, whether you can set it with a mortar, and you need the support of the manufacturer that's making the setting material in order to guarantee that you're going to get the bond. As we talked about earlier, there's multiple areas to take into consideration, and bonding is certainly one of them, the membrane to the floor and bonding to that particular membrane. Because in some cases it's required that you use urethanes to achieve that bond. Others are capable of with primers or with latex modified mortars. Another important step is to ask what your manufacturer's warranty is. Does his warranty relate to just the membrane? Does it relate to the membrane and the bond, or does it relate to the entire system where you're looking at bonding to the substrate and then bonding to the membrane with the tile? And how is that spelled out? And the other side would be from the installation perspective, when you're looking at cost, does it require anything unique or anything different in reference to the skill level of the installer, as that will drive up the labor cost. The final thing would be to look at the cost per square foot of both the material and the labor. Some of the membranes have excellent soundproof, but the cost of them is driven up in reference to the labor cost to install them. What I would like to do now is to turn this over to Robert to give you a little bit of detail on the testing side and some of the specific sound control testing, so you can get a view of what he does from an independent lab perspective.
Okay, thank you, Brian. Good afternoon. My challenge is to cover a lot of technical information and not get too in depth, so I'll see if I can do that. What you see on the screen is our laboratory complex that we have at NGC. We have 9 chambers. They're all heavy masonry walls, up to a foot thick, top, bottom, and sides. They're built on springs to keep them isolated from each other and from the building. Even the conduit that connects between the chambers have soft loops, so there's no vibration through the electrical conduits. The temperature and humidity are controlled. There are very specific dimensions and diffuser setups to meet the standards and have diffused sound fields. We continuously study these chambers over and over. Ours date back to 1965, and we'll have data for the last 48 years every couple months of how they perform. We're looking for consistency from test to test. Each one of the chambers has a separate test setup that some of them are for walls, floor ceilings, absorption. Right in this area here is a 2-story area. That's where we do the IIC, SDC, and Delta IIC tests. What we see here is stacks of assemblies. And the reason we have stacks of assemblies is that you need to test on the very specific assembly you intend to install in the field. Right now we have over 40 assemblies built, and we build new ones all the time to meet the very specific specifications. One thing I want to point out is that the IIC test, the SDC test, does not have a standard assembly in the specification, in the test E90 and E492 ASTM specification. E2179, which is Delta IIC, is the only one that has a standard assembly, and that's a 6-inch slab. Here we're installing one of our test assemblies into place. At our particular lab, the test assembly is 12 foot by 16 foot. This is put in place by overhead crane. The assembly is completely isolated once in place. It sits on a rubber gasket. The rubber gasket sits on top of a ledge that's part of the upper room. The upper room is supported by 4 independent columns that sit at independent springs. The upper and lower room do not touch. Additionally, along the perimeter of this assembly, we put in dry sand for additional isolation. All the sound that we produce needs to go through the test specimen and not through the adjoining walls or lab. Here's a standard tapping machine that we use. ASTM E492 requires 4 positions for this machine. The machine is heavily calibrated and checked. The hammer height, the hammer weight, configuration of the hammer tips, the velocity, taps per minute are all very closely controlled and checked based on ASTM standards. There's 4 locations. If you look right in this area, you can see little circles on the floor. That's the additional locations we need to move that machine to during the test. Here's an example of our control room. Here, what microphones, what speakers, what equipment we use for what particular chamber we're testing gets patched in. Now, the heart of the system is a computer and real-time analyzer. All the other equipment is more peripheral, but that's really the brains of the system. Here's an example of some raw data that we take during a typical IIC test. And this is just a portion of the data. Keep in mind that there's 4 tapping machine locations. There's 8 microphone positions per machine location, 32 measurements total with the tapping machine activated. Plus, we take another 4 measurements in the lower room for absorption, checks, and normalization, and 4 for background noise and 20 for absorption checks and normalization. So that's 60 measurements total at 21 frequencies simultaneously. It adds up to 1,260 points of data for every IIC test we do. So it's not just one test or one check. You're surveying both rooms and then doing a lot of normalization. So there's quite a bit of data collected. This next slide kind of explains how we calculate IIC. The red bars are actual data. That black, blue bar contour line, which is segmented into 3 segments, is the standard contour line. What we do is we shift that up and down until we hit a sum of 32 dBs across all the frequency above that line. Or if we reach 8 dB at one particular frequency above that line, then we stop shifting that. Wherever that contour line stops, we read across to the dB level and subtract that from 110, and that gives you your IIC value. This happens to be a 49. Here's an example of what we see on the computer screen during an actual test. The left side is one measurement in all the data we look at, all the different frequencies, those green bars are the frequencies. The right side is a graph of an actual test really at the end of the test. Now keep in mind at each frequency we round to the nearest dB, and then we fed it to that contour curve and do the other calculations. So a 49 or 50 IIC assembly may be almost similar, almost exactly the same, except it rounded slightly different, so it's a fraction off. The next couple slides are just some examples of what the curve looks like for different IIC ratings. Here is a 45 IIC. I think it looks like it's poor at the higher frequencies. It runs along the contour line at the medium to lower frequencies. Here is a 49 IIC. This does much better at the higher frequencies and poorer at the low to mid frequencies. And one thing to point out is right there is 8 dB difference, 8 dB above that contour line. That stopped that shifting. So this is a 49. If we did just a slightly better, fraction better at that 400 hertz, where that 8 dB hit, it would have been a 50. Here's an example of a 51. In fact, the last couple slides are an example of a 51. Much better at the higher frequencies and poor at the lower frequencies. But it's a 51, and the reason I'm showing you this is that the next slide is also a 51, but definitely a different contour. Here we have a very bad peak at the low frequency, poor but close to average at the mid frequencies, and pretty good at the high frequencies. This is still a 51, so the IIC doesn't tell you the whole story. What it does at each frequency says a lot. And it depends on what sound is being produced through that floor. What sound does it stop? Or even though it's the same rating. So basically, from a lab's point of view, to close, IIC and ACC ratings are only good for flooring on a specific floor assembly. For this reason, many different assemblies are needed in the laboratory. Remember that slide with all the stacks of assemblies. Although IIC and ACC ratings are the best system to compare products on like assemblies, sometimes they do not tell the whole story. We evaluate the performance, at least in the lab we do, of test assembly by examining different individual frequencies. An example is some of our clients may expect higher IIC results for perceived product improvements, but they do not see an increase in the IIC. But we may see substantial improvement at different frequencies when we're doing the test. But it might be limited by one particular frequency. That one slide with the 8 dB limited that particular assembly to a 49 instead of a 50. IIC and STC are single number ratings of overall performance of the floor assembly, kind of the weighted average of all the frequencies. How the floor assemblies performs on site, what people actually hear may be related to the individual frequencies and what's emanating the sound in the upper room. IAC and STC ratings of one or more assemblies that are 1 or 2 points different may virtually be the same based on rounding and maybe one limiting frequency. In fact, certain frequencies at the lower rated floor may be better than the higher rated floor, which blocks specific sound noises depending on the end condition. Also keep in mind, in generally, is that a 3 dB difference is needed for the human ear to detect the difference. So a 1 or 2 dB difference in performance in the actual field, you may not even show up with the human ear. Thank you.
Okay, what we'd like to do now is just open it up to questions from the audience. Any questions on any of the test procedures? Or
when a pre-sound code apartment building is converted to a condominium, do the sound codes affect the new change to the condominium?
I'm not sure I understand your question when it's converted.
Okay, you have an apartment building.
Okay.
The builder comes in, does remodel work, changes it to a condominium.
Okay.
Now, are the sound codes required for the new condominium?
See, that depends upon the association. A lot of times it really is developed in Florida. You can have some that will have a specification and some that won't. So it really depends upon the local codes and also the associations as to what they demand. There may be a local code in the association. The code may be 50, but the association wants a 55. So that's going to vary depending upon what the particular ownership of the building or if there is an association involved that is demanding higher performance. Yes?
I tried to remember by writing down my question, but the ANSI A116, I believe, is referred back to the quarter-inch grout joint.
For the grout joint, yes.
Okay, with today's materials, whether they be marble and tile specifically, or stone and tile specifically, we're going with tighter grout joints than a quarter-inch. And by you stating that a little bit later about the epoxy grout getting a better rating, because I'm imagining it's a tighter material. So if the grout joints like today are a tighter grout joint, does that mean that you're going to probably get a better rating with a tighter grout joint?
The question relates to the specification that we detailed on the example according to ANSI, and it was detailing, as you said, a 118.6 grout with a quarter-inch grout joint in it. And that was my exact thought when I looked at it is, if you're looking at a cement grout at a quarter-inch, you're actually exceeding what you're going to be doing in the field because you're keeping your grout joints tighter and you're having much less of them. But from the sake of doing a test, it's more of a worst-case scenario. And the reason for that is you're exposing more grout to the Robinson path of that wheel, and you're making a more challenging test than if you did a tighter joint for it. So from the sake of if it passes, you're in a better situation than if you were to have a run a tight joint and now you want to widen that joint and you're not sure if that would meet the Robinson test panel in the cycle. So to me, they picked 1/4 inch as representative to cover everything. And we do that from a membrane manufacturer as well with what tile we test, what material we test, bonding it to take more of the challenging side and to take the best case scenario so that you know that when things are stretched that you're covered. If that makes sense?
Yeah, no, it makes sense. And then how about, because today we're getting into so much larger module materials, and so where installation is going to be paramount to a proper reading. So obviously you guys in the laboratory are going to get them to say if it's 85% coverage is necessary, but then you find out the material, has got a pretty heavy bone and the person didn't back butter it. Now you're getting something that even though by ratings that it was tested at might not produce that rating in the field. And if I remember these tests, don't some of these tests have to actually take place in the field?
You can do field tests, but what we were looking at earlier when we talked about field test is the many variables that you're exposing yourself to in a field test. And that's certainly one of them that is a variable as to how the product is actually installed, because if it is not installed properly, you're definitely going to get variables in reference to the Robinson and its performance under stress or its shear bond performance, and probably the sound will probably be improved if you have hollow tile. Not that it's beneficial, but but on that side, I mean, it's a consideration that airspace does result in better sound control. But as we said, it's a combination of all of those factors that you're really looking to achieve in reference to the bond of the membrane, as well as the sound and its resistance to mold and mildew and the entire package. But when you're looking at thin tile, another consideration is also that thin tile is rated for a floor installation. Many of the tiles are designed very thin in nature, but they're not designed for the floor. So there's some confusion in the industry in reference to where they can be used, and there needs to be clarification on the manufacturer as to the acceptability of that tile for a floor application. But we've done a lot of Robinson test panels on thin tile, and as you point out, it is extremely important that you have coverage and that you use the proper setting materials and methods for those. And to me, it's the double-edged sword. To me, it's the most opportunistic tile in the industry, but it's also the most challenging from a perspective of if we don't do it right, it will limit our success with it. Other questions? If there's no other questions, you're free to finish off the 200-page exam. And, thank you very much for your time. Appreciate you coming in and your participation.
Thank you.